1-1, solving an equation that has variables on both sides. That's what we're doing today. You might remember last time we went over multi-step equations. This is kind of just a expansion on that and tricks to get the equation looking how you want it, so that way you can solve it effectively. Let's start with our focus question. How do the properties of equality help solve an equation with variables on both sides? Let's talk about the properties of equality real quick. The first one is simply the addition property of equality, but instead I'm just going to refer to it as the operation itself, the addition property. It says that if I have an equation like in this first example here, I can add 1 to both sides, and what that will do is eliminate this -1 on the left side, so we're only left with x. And then on the right side, 4 plus 1 is 5. So here I solve the equation with only that property. And you'll see that goes for every example down this list, at least for the different properties. The subtraction property is very similar. You might be able to guess what's going to happen here in this example. I'm going to subtract a 3 from each side. Okay, very important you do it to both sides. Otherwise, it's not a balanced equation. After I do this, on the left side, all I have is x. And on the right side, -2 minus 3. Okay, be careful with negatives. -2 minus 3 is -5. Okay. Multiplication property. This helps us get rid of fractions. You might notice that we have a fraction here, a x divided by 3. What we can actually do, is multiply both sides by 3. Okay. The reason I can do this, and the reason I want to do this, is that I can actually eliminate the 3 in the denominator of that fraction, leaving me with just x on the left side. And 4 times 3 is 12. So here we got our answer by multiplying both sides by 3. Okay, that goes along with, that nifty quality of any number divided by itself is equal to 1, which is why we're allowed to do this and get rid of that 3 in the denominator. Okay, division property. This is used to undo multiplication. You might notice something here. Here I have addition. I have to use subtraction to solve it. Here I have subtraction. I have to use addition to solve it. These are inverse operations. They undo each other. For multiplication, since I have this division going on, I have to use multiplication. For division, whenever you see multiplication going on, and remember, we don't always write that two things are multiplied. I'm going to put a dot there to show that they are. To undo that, we have to use the division property. So we're using the inverse of multiplication. Here, I'm going to divide both sides by 2. And in a very similar way to the last problem, this fraction clears out. It leaves me with just x. Is equal to 12 divided by 2 is 6. Okay. So that's essentially the properties we're going to use. Let's move on to the second part of the focus question. What other mathematical properties are sometimes needed? You might need the distributive property. Okay, the distributive property. What this property is it essentially lets you multiply things and get rid of parentheses. So for example, let's say we have -3 times x plus 1. Okay, if I wanted to get rid of those parentheses, I could use the distributive property to multiply everything inside those parentheses by the outside. And hopefully we saw last time that we can do this with numbers and variables as long as we have this plus or a minus in between these two terms here. -3 times x is -3x. -3 times +1 is -1. Okay, so that's just how the distributive property works, and we'll get into how that's helpful when we look at the steps to solving an equation. Okay, I'm just going to read out these 5 steps. Hopefully, you'll see exactly how they work in the examples if you're not sure just by reading these. Let's start with step 1. Use the distributive property to remove any grouping symbols. Okay, this really means, and I've highlighted what I put in my own words here, this really means get rid of the parentheses. Because a lot of times you end up in a situation where x is inside of parentheses, and remember, we want to isolate x to solve the equation, so we really need that step 1 just in case there's any parentheses or grouping symbols involved. Step 2, combine like terms on each side. We talked about combining like terms in the first day of the year or second day of the year. We talked about combining like terms. This is essential to get rid of the clutter, and you'll see what I mean when we do the examples. Step 3, get the variables on one side, so all your letters, all your x's or m's or whatever they might be, get all those variables on one side of the equation, and then push all of the constants to the other side. This lets you get to something closer to what we want, right? Variables on one side, constants on the right. That way we can get closer to our answer. Step 4, solve for the variable, isolate the variable. This goes as any equation you've done before. Okay, so after this point, it gets a bit easier. Step 5 is to check your answer. You got to plug it back into the original question to make sure it works. If you don't check your answer, you could get it wrong. Okay, so at least you'll know if you're incorrect rather than guessing and assuming that you are. Let's do some examples. Okay, problem 1. You'll see that I put these steps to solve this equation over here at the left side. These are the same steps from the previous slide. I'm going to keep them here for at least the first handful of examples. That way we can still refer to it, but you will not have this at all times. Usually I would put it on a poster in my room, but you won't see my room for at least a bit. So let's keep these in mind while we solve this. I'm going to go ahead and rewrite this equation right here. The reason that I rewrite it is just to make sure I know what I'm talking about. And also because I want to do some crossing off and I don't want to have to erase that on my page later. Okay, so this is my equation. Step 1. Okay, step 1 says to use the distributive property to remove any grouping symbols. The thing is, there are no grouping symbols. There are no parentheses, so we've got step 1 taken care of. Nothing is going to happen there. So I'm just going to put a check on step 1. We've done that. Okay, there are no grouping symbols to deal with here. Step 2, combine like terms on each side. Remember, like terms have the same number or quantity of variables. Okay, or they have the same variable on both sides. Like terms, for example, I could combine the 5x and the 2x. The only problem is they're not on the same side. So if I just looked at the left half, there are no like terms. Here I have a 5x and a 2. Those are not like terms. And on the right side, I have a 2x and a 14. Also, those are not like terms either. So that means that step 2 is complete. We don't have any like terms to combine. Step 3 says get the variables on one side of the equation and the constants on the other. I'm going to go ahead and highlight my variables or my variable terms in yellow. Okay, so I have a 5x and a 2x. I want those on the same side as each other. And then in green, I'll highlight the constants. Remember, constants are just your average numbers, like this plus 2 here, this positive 2, and this positive 14. Okay, so I want to move the green stuff over to one side and the yellow stuff over to the other. Usually you want the variables on the left. It does not matter, as we'll see in the future. Let's see, so how are we going to go about doing this? The first thing we can do is try to get all my x's over to the left side. So what we can do is use the subtraction property, which tells me that I'm allowed to subtract a term on both sides. What this is going to allow me to do is cancel or eliminate that 2x on the right and move it over to the left. So I have 5x plus 2 minus 2x equals 14. Okay. Now what I like to do is take a look at step 2. After every time you go through something, take a look at step 2. Maybe we can combine some stuff. I see two like terms here. I have 5x minus 2x. Okay, 5x minus 2x is 3x. So I combine those like terms there. Okay, and we still have that plus 2 to take care of. Okay, now that I want my variables on the left, I need to now move my constants over to the right. And I'm going to use the subtraction property once again to move this 2 over to the left-hand side. 3x is equal to 14 minus 2 is 12. Okay, and now we're getting closer and closer to that step 4. We're getting closer and closer to isolating that variable. The last thing we need to do is realize, okay, well, what is happening to x and what do I need to do to get it by itself? Right here I have 3 times x. 3 times x is multiplication, which means that the inverse operation that I need to use is division. So we're going to divide both sides by 3, and that should get rid of the 3 there. Here I have x equals 12 divided by 3 is 4. Okay, I'm going to box off my answer, but you should be doing this in pencil. Why? Because step 5 is to check. So how are we supposed to check this? Let's see. Let's do it up here up top. Okay, what I'm going to do is rewrite this equation. So I'll put check here. Okay, I'm going to rewrite this equation so that I'm going to leave space to plug in that value that I got for x. So every time I see an x, I'm going to leave a little space to plug it in. Okay, this is just us checking our answer. I'm going to plug in x equals 4, which is what we got, or what we should have. And I'm going to check and make sure the left side equals the right side. 5 times 4 is 20, I think. Use a calculator, by the way. 5 times 4 is 20. Plus 2 is 22. Is that equal to 2 times 4 plus 14? 2 times 4 is 8, plus 14 is 22. So I know that these work, and that's all steps complete. Let's do another one. Actually, let's take another look at that problem and see if we can do it another way. And you might have been asking yourself this. Regardless, do I have to move the variables over to the left? Or does it matter which side I choose? It actually doesn't matter at all. What I'm going to do now is the same equation, except I'm going to start by subtracting 5x from each side instead of the 2x. So I'm going to subtract a 5x from each side, like they're telling me to do, minus a 5x. That's going to cancel this 5x here and leave me with just that constant 2 on the left side. 2x, let's see, we still have 2x plus 14. We can subtract a 5x now. And you might have skipped this step, but I like to write it all out before I start combining like terms. So let's see, 2x minus 5x is, well, actually, you know what? Let's do it a little bit different than last time. Let's subtract a 14 from both sides. That way we can complete step 3, because I really want to complete step 3. So let's just move everything onto its own place. Okay, 2 minus 14 is negative 12 on the left side, and over here the 14s will cancel. 2x minus 5x is still over here on the right, and now it's clearer to see that if I take 2x minus 5x, I can combine those terms straight away. 2 minus 5 is just negative 3, and 2x minus 5x is just negative 3x. Still have a negative 12 over here. Now you might be saying, okay, where are we in the step process? Really, we're all the way over to step 4, where we're ready to isolate this variable. It doesn't have to be on the left. Okay, if it's on the right, I'm not going to take points off. Okay, that's your preference. However, a little bit of a tricky situation here. I have multiplication happening to x. I need to take care of that. And in order to do that, I need to use the inverse, which is division. Now be careful, I can't just divide this by 3. Because x is not being multiplied by positive 3, it's being multiplied by negative 3. So in order to cancel it on top, I need to be able to divide by negative 3 on both sides. Okay, now back to before quarantine. Let's think for a second. A negative divided by a negative is a positive, okay? Negative 12 divided by negative 3, and you can check this with your calculator or your phone. Negative 12 divided by negative 3 is positive 4. And that's the answer for x. Now, is that the same as what we got last time? Absolutely. We just wrote it the opposite way. Okay? X equals 4, 4 equals x. These mean the same thing, which also means that we don't have to do step 5 because we've already checked this value of x. Let's do a new problem. Problem number 3. What is the solution of this equation? Let's rewrite it real quick. By let's, I mean I'm going to rewrite it real quick. It helps me think about it. 4k minus 10. Okay, notice that we're using k instead of x. It does not matter. Treat them the same. We still want to isolate that variable. Let's do it step by step this time. I'm not going to skip any. Use the distributive property to get rid of any parentheses. I don't see any parentheses, so step 1 is done. Step 2, combine like terms on each side. This looks just like the last problem. Here I have a 7k, which is not a like term with this positive 2. Okay, and there's the same thing going on the right side. Okay, 4k and negative 10, those two terms are not like terms, so we can't combine any, so we're done with step 2. Let's see, step 3, get the variables on one side and the constants on the other. Okay, I'm going to move my variables over to the left, but let's start with the constants first. Let's take care of those constants first. So I'll highlight them in green. We have a positive 2 and a negative 10. Let's move those over to the right side. To do that, I need to get rid of that positive 2 on the left. 7k plus 2, that's an added 2, so I need to use the inverse of addition by subtracting 2 on both sides. This leaves me with just 7k on the left, and 4k negative 10 minus 2, well, I can rewrite here, minus 10 minus 2, just so we don't get confused. Okay, let's not combine those yet. Next thing I'm going to do is move my variables over to the left. To do that, I need to subtract this positive 4k on both sides. So now we're left with 7k minus 4k equals negative 10 minus 2, since these will cancel each other. Now, on both sides, we have like terms to combine, so let's do that. 7k minus 4k is 3k. And calculator check real quick, right? Negative 10 minus 2 is negative 12. Okay, I have multiplication here at the end, so I need to divide both sides, once again by the number 3 this time. Dividing both sides, I get that 3 canceled. I have k is equal to negative 12 divided by 3. Okay, a negative divided by a positive is a negative. So negative 12 divided by 3 is negative 4. But wait, we're not done. We have to check the answer. We're going to do it just like we did last time. So we'll take this equation. We're just going to check. Okay, we'll take this equation. We'll go over here. We'll just say 7 times our value for k plus 2 is equal to 4 times our value for k minus 10. Okay, let's plug in that answer that we got, negative 4. Okay, now you work out both sides and see if you still got the same thing. 7 times negative 4 plus 2, you could type that straight into your calculator as I said it. 7 times negative 4 and then add a 2 to it. You're going to get negative 26, I believe, if you type it in, negative 26. Okay, and then you just have to make sure the right side also equals negative 26. And it's good. It's negative 26. Okay, so we checked it with our calculator. We did all the steps. We combined all the like terms. Let's do another one. Hopefully you're starting to get the hang of things. Let's go. Problem number 4. First thing I want to notice and mention to you is that we're not at school yet, which means that you can use this calculator on your phone. If you turn off your screen lock, you can use even more features on it. I'm going to use this for this entire problem because this is all about knowing when to trust your calculator instead. So a lot of times you can't do the mental math because you're dealing with things like decimals. Okay, let's rewrite this equation just so you see where the problem is here. 24.1 g minus 35.78 is equal to 6.9 g plus 587.72. Okay, so now you kind of see the issue. The calculator part will come in handy, but the first couple of steps are still the same. We still don't have to worry about step 1, no parentheses yet. We don't have to worry about step 2, because essentially, step 2, combine like terms on each side. Well, we still know where the variables and where the constants are. My variables in yellow, these variable terms are not on the same side, so we can't combine them, and these constant terms are not on the same side, so we can't combine them. So we have to move straight to step 3, where we move everything over to where it should be. Now let's start by moving my constants over to the right and my variables to the left. So let's start with the constants to the right. Let's get rid of that constant on the left. So to do that, I need to add 35.78 to both sides. 35.78. Okay, now is the part where you need your calculator, okay? There are some things at this point that we could still figure out. 24.1 g, those will cancel on the left, is equal to 6.9 g plus whatever this turns out to be when I add those two numbers together. So let's get the calculator. 587.72 plus 35.78. Okay, I got 623.5. Okay, and this is where it becomes super important to check our work at the end, because I mean, I would always calculate it twice just to make sure. So I moved my constants over to the right. Let's move my variables to the left. I'm going to do that by taking care of this 6.9g with subtraction. We're going to subtract 6.9g from both sides. Okay, and I'm not going to combine these two terms yet, just so you can see exactly how I calculate it. Okay, since that cancels on the right side, all I get on the right side now is 623.5. Okay, now here's exactly what I'm going to type into my calculator to figure out how much g we have left after I do the subtraction. So I'm going to take, oops, held my phone upside down. I'm going to take 24.1 minus 6.9, and I get 17.2. G is equal to 623. Oops, completely botched that. 623.5. Okay. Now you might be thinking, okay, well, are we finally to step 4? Yes, we are. We're going to try to isolate this variable. Okay, so we took care of step 3. We're going to try to isolate that variable. And just because there's decimals doesn't mean anything's changing here. I'm still going to divide both sides by whatever coefficient is in front of the variable. Okay. Since that coefficient is multiplying g, I need to divide it in order to get rid of it on both sides. Now is the part where you definitely need the calculator. G is equal to whatever this is right here. You definitely need a calculator. I'm going to take 623.5 divided by 17.2. I got 36.25. And I'm going to box that answer, but I wouldn't yet because we still haven't done step 5. Check. Okay, how do you check this? With this. Okay, you honestly do need this. What I would do, honestly, is, let's see, 36.25. I would just plug it into the left half. So this is my left half of the equation. 24.1 times g, which we found to be 36.25. Okay, minus 35.78. And then you throw that into your calculator. Skip the calculation. Okay, make sure you hit enter after multiplying these two and then subtract. Okay, this is what I got. I got 837.845 on the left. So let's just make sure that's the same thing that we get on the right. Plug that in. 6.9 times 36.25 is equal to 250.125. Okay, if we add 587.72, we get 837.845. And if the left matches the right, we have completed step 5, and we know that our answer is correct, even when there's decimals flying around. Let's try another one with decimals. Okay, I'm going to go a bit faster on this one just because this is very similar to the last problem, except, oh, now we're dealing with the familiar x instead of what we usually deal with. Once again, no parentheses to deal with yet. Combine like terms on each side. We're going to skip that step, it seems. Yeah, once again, we have our variables in yellow, our variable terms on opposite sides of the equation, and we have our constants on opposite sides of the equation, so we can't combine them yet. Okay, we can move on to step 3 though, which just says let's move the yellow over to whichever side you want and the green over to the other side. As long as they're on opposite sides, that's fine. I always like to stick with one method because I mess up less often. I like to move my variables over to the left and my constants to the right. Okay, if I want to move my variables first, let's move the variables first. Let's move this term over. It's minus 1 or negative 1.15, so I need to add 1.15x to both sides. Okay, that will get rid of it on the right, so we're just left with 2.06. Didn't mean to write that in red. We're just left with 2.06. Okay, on the left side, I need to figure out whatever 3.1x plus 1.15x is. I need to combine those pretty soon. I'll save them for now. Let's go ahead and leave all the calculating for last. That's what I like to do. Let's move this constant, this positive 9.2, over to the right side. So that way we can get rid of it on the left. 3.1x plus 1.15x is equal to 2.06 minus 9.2. Okay, it's now calculator time. Let's go ahead and combine these two like terms. To get this, I'm just going to take 3.1 plus 1.15 and hit equals, and I got 4.25x. Okay, don't forget the x on the left side. And then on the right, I can just hit clear. I can take 2.06 minus 9.2, and we get negative 7.14. Okay, we are very close. In fact, we are upon step number 4. Let's go ahead and isolate that variable x. Once again, we're going to have to use division on both sides. And once again, we're going to get some kind of crazy variable. Or some kind of crazy fraction, excuse me. I don't know my own words. Okay, so these 4.25s will cancel because I divided. That's the opposite of this multiplication happening here. So I just get x on the left. And now I need to take my calculator. And don't forget the negative. To do it on an iPhone calculator, by the way, 7.14, you type it in and then you hit this little plus minus button. That makes it a negative. So that's negative 7.14 divided by 4.2. I got negative 1.7. Now, just like you should do, I'm going to cut this out of the video, but I'm going to check my answer, and you should too. And this is why you always check your answer, because I did this again in my calculator and I didn't get 1.7. I got 1.68. So check your answer. Now we should be okay. Sorry, 1.68. That should be it. Let me check. Okay, my left side matches the right side, which means that now we are correct. That's just I left that in just to show you. It's very important to check your work. Let's do the next problem. Next problem. Okay, this is the part where you got to write your own equations to solve a real world problem. In this case, this guy's trying to save some money. An office manager spent $650. Okay, so we'll put that as, that's bad. $650 on a new energy saving copier that will reduce the monthly electric bill for the office from $112 to $88. Okay, so they're spending money to make money, essentially. They're trying to save some money. If you're paying $88 a month, that's way better than $112 per month, right? That's going to add up quick. In how many months will the copier pay for itself? It's essentially asking, in how many months will the copier pay for itself? So to answer this, we have to do a few things. We have to define a few things. First of all, before we can even write an equation, we need to define a variable. Okay, and we have to think, okay, look at this problem. What's going to be the factor here? What changes? What do I need to to change over time, or not even over time, but what is my changing number here? What is unpredictable? I know that it's $88 per month now after they save some money. There's a base cost of $650. That doesn't change. A constant, so that's $650 is a constant. And then we have $112 per month as what they were paying before. We can see that the thing that's changing is the number of months. That's really what's going to be important here, okay? Because essentially we want to know how many months before these two things will balance out. Okay, so let's just call that X. You could use M, you could use any letter that you would like. I'm going to use X. Let's do a few calculations. Now, if you do it this way, you're going to be very bored. It'll take you a long time. But essentially, you could think of it like this. Before they were paying, I'm using my calculator here, before they were paying $112 per month. So let's just talk about before. After 0 months, well, they still didn't pay $112 because there hasn't been a month yet. But after 1 month, it cost them $112 total. Now, how much would it cost after 2 months? Well, it'd be 112 plus 112, which is $224 after 2 months. Okay, you'll notice the pattern here. After 3 months, it would be 112 plus 112 plus 112, or you could just do 3 times 112 to get 336. Okay, and notice that the cost is proportional to the number of months that have passed. So if I had X amount of months, right? I don't know the number, but I want to write an equation or an expression. After X amount of months, how much would it cost? Well, it's going to be 112 times X. Okay, so that's my expression for how much it costs every on X amount of months. Let's do the same thing for the cost after. First of all, there's something different. After 0 months, they did spend some money. They spent $650 up front. So month 0 is going to cost them way more. Okay, there hasn't been any months yet, so we don't have to worry about the 88 yet. After 1 month, it'll be 88 plus 650. Okay, the 650 doesn't change. That's just there for the total, which is about, let's see, that is 738, I believe. Okay, on the second month, we're going to have to take 2 of those $88, voice crack, and we still have the 650 at the end. Okay, so it looks like it costs a lot more. 2 times 88 plus 650. We get 826 total. On the third month, we could take 3 times 88, add the 650. 3 times 88 plus 650 is 914. Okay, so you can see that at first, it's going to cost way more. Okay, we can still write an expression though, because eventually, since we are spending less per month, eventually we'll get that $650 back. So let's write an expression for this. After X amount of months, the total is going to be X, well, 88 times X plus 650. Okay, we have to keep the 650 in there because it came with the cost of the machine. So we have these two expressions, and what I'm wondering here is, when will these be equal? Okay, and when I say when, I mean what month? And when I say what month, I mean what value of X? Okay, so what value of X will these two expressions, and I'll highlight them here, these two expressions be equal? Okay, so we're solving for X in that equation. Let me write that equation and clean up some stuff. We'll be back in a sec. There we go, just like magic. Okay, now I set these two equal to each other, and we need to figure out what value of X will make this true, right? What value of X makes these two parts, right? I'll highlight them here. What value of X makes these two parts equal to each other? Now, let's start by remembering the rules that we talked about at the very beginning of this video. Rule number 1 is to make sure that there aren't any like terms that you can combine. Okay, rule number one is to make sure there's no parentheses, or get rid of the parentheses if you need to. We will get to that later. Step two was to make sure that there aren't any like terms that we can combine up front. And step three was to move all the variables to one side and move all the constants to the other. And since I got a constant on the right and a variable on the left, I'm going to go ahead and move all my variables to the left side. So to do that, I'm going to subtract an 88x from both sides to get rid of that. Now it's just like a normal problem. Okay, 112 minus 88, I can't do that in my head. 24x on the left side is equal to 650. Okay, so now what we're asking is, okay, what's that value of x? To get that value of x, we need to get rid of the 24. That coefficient of 24, we can get rid of that by dividing both sides by 24. So x is going to be equal to 650 divided by 24, which is 27.0833 repeating. Okay, now that might seem weird. Okay, I thought we were looking for the number of months. Okay, it says in how many months. We could approximate this to 27 months. Okay, how do we know that this is true? Well, we still have to check. We still have to do step 5. In order to check, we have to make sure that whenever I plug in our special value into this equation, I have to make sure that it is still true. Okay, so in this case, we need to plug in x equals 27. So after 27 months, these two should be equal. So check the left side versus the right side. Okay. Looks like we're all set. This is correct. Okay, so my answer is, let's box it off, x is equal to 27 months. Let's do another one. Let's get away from word problems for a bit and let's do some other properties. Let's get into what step 1 is really about. Let's do that. Okay, next problem. We need to be able to use the distributive property, because you'll notice on my next equation here, I have parentheses. Let's rewrite it real quick. 2 times 5x minus 1 is equal to 3 times x plus 11. And I went ahead and wrote the distributive property over here. That's what we'll need in order to get rid of those parentheses. Notice that I have parentheses before and none after. So that's exactly what we're going to use the distributive property for. Remember that the distributive property lets me multiply the insides and get rid of those parentheses. Let's do that on the left first. Okay, I know that I have to take this coefficient outside, this number 2, and multiply it by everything inside and add up all those terms. We have 2 times 5x plus 2 times negative 1. Okay, and that's equal to, let's do the same thing over here. Okay, this time we're dealing with a 3. 3 times x, well, we can just write 3x. We don't have to put a parentheses there. 3 times 11 is what we need to add next. Okay, now let's start simplifying. First of all, if you're skipping steps, that's totally fine. I'm just being extra careful here since this is the first problem of this type. I will skip some of these steps later, and you'll see what I mean right now. For example, this 2 times negative 1, 2 times negative 1 is just negative 2. Okay, so instead of plus 2 times negative 1, we'll just put in negative 2. There's some other things we can simplify. 3 times 11 is 33. Okay, and 2 times 5x is just 2 times 5 is 10, and we still need to keep the x, so we have 10x. So I have 10x minus 2 is equal to 3x plus 33, and at this point, we have completed step number 1. The parentheses are gone. There's no more grouping parentheses, there's none of that. Step number 1 is done. Combine like terms on each side. We still don't need to do that yet. Step number 3, get the variables on one side. So my variable terms are 10x and 3x. Let's get those to the left. And my constants over to the other side, which are negative 2 and positive 33. Okay. To get all my variables to the left, I'm going to subtract a 3x from both sides to get rid of that. 10x minus 3x is 7x. We still have a minus 2 and a 33 on the right. We're going to move that negative 2 over to the right side by adding a 2 to both. So we get 7x is equal to 35. Okay. Now all we need to do to finish this off is to make sure we complete step number 4, which says isolate the variable. To do that, we need to divide both sides by that coefficient of 7. Okay, 35 divided by 7 gives me 5 on the right side. Get my pen there. 5 on the right side, and these 7s will cancel, leaving me with just x as my answer. Step 5, check your answer. Okay, so plug this in up there and check your answer. It's actually going to be a bit more of a pain, but I highly recommend you do it. You basically just have to make sure that the left equals the right whenever you plug in your value of x wherever you see it. Now this might look like a lot of parentheses, but essentially I'm just making room to plug in that variable, to plug in that solution that we found, 5. Okay, let's see. Let's leave the first set of parentheses and let's just do the stuff in between. 5 times 5 is 25, minus 1 is 24. Okay, 5 plus 11 in this parentheses gives us 16. Okay, 2 times 24 is 48. 3 times 16 is also 48. So we have checked it, and that is step 5. Let's do some more. Problem 10. We need to get rid of these parentheses to even start solving this equation. That's step 1, get rid of parentheses. To do that, we need the distributive property, which tells us that we need to multiply the insides of these parentheses terms by the coefficient on the outside. So on the left, we have the 7 on the outside, so it'll be 7 times 4 plus 7 times negative a. Okay, and that's equal to, let's skip some parts here. 3 times a is 3a. 3 times negative 4 is negative 12. Okay, let's simplify a bit on the left. 7 times 4 is 28, I believe. And 7 times negative a is negative 7a. Nothing's changed on the right. I was just simplifying a bit. Okay, so now that we're here, we've gotten rid of the parentheses. Step 1 complete. Step number 2 says that I need to combine like terms. There are none on both sides, so we are good there. Step number 3, let's start moving our variables. This time I'm going to mix it up. Let's move our variables to the right, and let's move our constants to the left. Okay, so in this case, I want to move this term, negative 7a, to the right. To get rid of it, I need to add 7a to both sides. That will cancel this term and leave us with just 28. 3a plus 7a is 10a, and we still have minus 12. Let's get our constants over to the left now. Add 12 to both sides. Gets rid of that negative 12. 28 plus 12 is going to be 40. And that's equal to 10 times a. We need to finish off step 4 here by dividing once again. So divide both sides by 40 or 10. It's going to be 10 because remember what we're trying to do here. We're trying to isolate the variable, and this time we put the variable on the right, and that's fine. Divide both sides by 10. Cancel that 10 on the right. 40 divided by 10 is 4. And on this side, we're just left with a, our answer. All you have to do is check this answer in the problem above, and you'll know you're right. Feel free to do that on your own, because I'm moving on. Okay, take a look at this problem here. What we have here is an equation. Step 1, try to distribute and get rid of those parentheses. I only see them on the right side, so we'll just do it to the right side. 2 times 5x is 10x. 2 times 6 is a positive 12. Okay. And we're not going to do anything to the left, and you already noticed something wrong. If you keep trying to solve this, this might be your next step, for example. Okay, you'll see that there's something wrong here. If I subtracted a 10x from both sides, I get 0 equals 0. What does this mean? Well, it means that if you look at this side of the equation and this side of the equation, no matter what number you plug in, both sides are equal. It was just kind of pretending like that wasn't the case up here. So this has infinite solutions. Or you could put this special symbol called all real numbers. It's an R with 2 slashes through it. It basically means all real numbers will work and it will still be true for this equation. Let's look at some more weird ones like that. Okay, let's take a look at this problem. Let's see if anything weird happens here. Once again, I'm just going to start as normal. Step 1, already done. Step 2, I got to combine like terms. Oh, for once, I actually see 2 like terms on the same side. I'm going to write them next to each other just so you can see how we should combine them. I'm going to put the -1 to the right of the +1. Doesn't matter which order I put these in, by the way. Once I combine these, 12m minus 3m is 9m. Still got the 5 on the m on the end. 9m minus 4 on the left. Okay, so what do we got here? We have another problem. Okay, add 4 to both sides to try to get our constants over to the right. We get 9m is equal to 9m plus 1. Okay, what you'll notice here, once we're to this point, is that if I were to subtract a 9m from both sides, I would get 0 equals 1. That's not true for any equation. That's not true for anybody out there. So what you need to realize here is that there's actually no solution to this. There's no number that I could plug in that would equal itself plus 1. Okay, there's no number that I could put in here that would equal itself plus 1. So this has no solution. Okay, whenever you come into something like this, something weird and something that you know is wrong, you either know it has either infinite solutions or no solutions. You just have to do a little bit of extra thinking to figure out which is which. Okay, this next problem. Let's try to do this one. I chose this one because now, not only do we need to do step 1, but we need to consider that my coefficient here is a -1 on the right side. Let's leave the left the same. -1 times 3 is -3. -1 times -2x, negative times a negative, is a positive 2x. Okay, now that we're here, we can start simplifying some more. Let's go ahead and add a 3 to both sides just to get rid of that 3. 2x plus 10 is equal to 2x. Okay, let's see. And here we come across the same weirdness. Okay, hopefully you see what I'm saying about now. If I were to subtract a 2x on both sides, you then come to the conclusion that, oh, okay, 10 equals 0, and that doesn't make any sense. This has no solution as well. Okay, I hope that video was helpful. If it wasn't helpful, email me or message me on Canvas. This video was long enough. I'm just going to end it here. Goodbye.